Hi everyone! So for this video we're going to go over alkene addition reactions that have anti-stereochemistry. And what we're going to learn, the big major takeaway from this video, is that alkene addition reactions with anti-stereochem all have a 3-membered ring intermediate. So let's get started. Okay, so we're going to use our model reaction. Is just going to be a butene. So let's say we're starting with this butene and we're going to add the different reagents as listed below. So something that we can do to get a ring intermediate is dihalogenation. So that's Br2, I2, Cl2, right? So if we react butene and Br2 together, we'll get something like this, or we have the one bromine going towards us and one coming away, and we'll also get its enantiomer. Perfect. Cool. So we can do the same thing also with dihalogenation, and also we could add a nucleophilic substrate such as ROH. It's going to change our products slightly. So let's pretend it's Br2 and ROH. So we get one Br coming towards us, one OR going away, and also its enantiomer. Oops. Okay. Okay. And we can do oxymercuration as well. So that'll give us HgOAc2 and NaBH4, NaOH, our reagents, and our products will be OH and hydrogen, and it's an enantiomer, of course, as well. And the last thing that we're going to go over that has a ring intermediate is an epoxide. And we can react this epoxide with, let's just do H plus and H2O. And these are going to be we'll get 2 anti-OHs. If you haven't learned the epoxide ring opening reaction yet, don't worry about it. But if you are curious, you probably have already learned this 2-butene reacts with MCPBA. That's where we get our epoxide. And then you could use this step here where you're reacting it with some sort of nucleophile to open up our ring. And the ring opening step is where we get the anti-product. Okay, so now let's try to really figure out why this 3-membered ring intermediate makes it so that we're going to have an anti-product. So let's just start by analyzing the mechanism. Okay, so the reaction I want to go over is Br2 and adding ROH as a solvent. Okay. So we'll draw out all our electrons here. Perfect. Okay, so our pi bond is going to come and attack this bromine because it's partial positive, although it may not look it. And this set of lone pairs here is going to come attack this carbon. And so we're going to get something that looks a little bit funky. This 3-membered ring intermediate. And if you want to calculate formal charge, you'll figure out that bromine has a positive charge. Always remember to be calculating formal charge throughout. Okay, so now we're left with 2 nucleophiles in solution. We've got Br minus and ROH. And ROH is actually a better nucleophile, so it's going to attack the ring instead of Br minus. So as we can see, this oxygen is going to be attacking from behind the ring. Now it's going to kick off these electrons onto bromine, and our product or I guess this is still technically intermediate. So we get ORH. And now this bromine is coming behind us. And we'll have some base ambiguously come, deprotonate. So we're left with OR and BR. And also, of course, the other possibility when drawing out the ring is for it to look something like where this set of lone pairs comes here, but we're actually drawing it up here, and our ORH comes from the bottom to attack. And now our bromine should be wedged, and our ORH dash. So hopefully now it's a little bit easier for you to visualize why this 3-carbon ring intermediate makes it so that you're going to have anti-stereochem, because it's attacking from one side and kicking it off onto the other. And as we can see here, the same thing's happening. Our ORH is attacking from the bottom. It's kicking bromine up to the top. So yeah, anytime you have a 3-carbon ring intermediate like that, definitely remind yourself it has to be an anti-stereochem. And I hope that as you're going along, you're trying to develop different strategies to not just memorize whether it has syn or anti-stereochem. You're really trying to understand why it does. And looking at this 3-carbon intermediate is a great way to do that. So I hope this video helped.